Hi children, good morning. This is Navina. You people learned about common factors and multiples in the previous class. Today we are going to learn some more divisibility rules. The first rule is that if a number is divisible by any number, it is also divisible by each of its factors. Means children, if we take any number and for example if you are taking 248, it is divisible by 8. And we know the factors of 8 are 1, 2, 4 and 8. So by this rule we can say that 248 is divisible by 1, 2, 4 and even 8 also. Okay. For example, let us take another example. 24 is divisible by 12. Here, factors of 12 are 1, 2, 3, 4, 6 and 12. We already know that it is divisible by 12 and by this rule we can say that 24 is divisible by 1, 2, 3, 4 and even with 6 also. This is the first divisibility rule. Okay? Yeah. The next divisibility rule is that if a number is divisible by two co-prime numbers, then it is divisible by their product also. Yeah, this is very interesting one children. Let us discuss with the example 18. I am taking 18 ma. So here 18 is divisible by 2. Everyone knows the divisibility rule of 2. And it is also divisible by 3. Means 18 is divisible by 3. Okay, now 2 and 3 are co-primes, right? Because the HCF of 2 and 3 is 1. So by this rule we can say that 18 is also divisible by the product of 2 and 3, that is 6. Means 18 is also divisible by 6. Okay. Um, Let us discuss with another example. I am taking 100. 100 is divisible by 4 and we know that 100 is also divisible by 5. And we can say that 4 and 5 are co-primes because the HCF of 4 and 5 is 1. So here the product of 100 is also divisible by the product of 4 and 5, that is 20. Means 100 is divisible by 20. This is the second rule. Okay. Yeah. The next divisibility rule is that if two given numbers are divisible by a number, then their sum is also divisible by that number. Okay. This is means let us discuss with one example. I am taking 16 and 32. 16 is divisible by 8 because you know the divisibility rule children, and 32 is also divisible by 8. Here I am taking 16 and 32 and I am telling that 16 is divisible by 8 and even 32 is also divisible by 8. Now if you add 16 and 32, you will get 48. And finally we say that by this rule, if you after adding that numbers, you are getting 48 and this 48 is also divisible by 8. Okay. Let us discuss with another example. Take 9 and 12. Here 9 is divisible by 3 and even 12 is also divisible by 3. Now adding 9 and 12 you will get 21. Here by this rule after adding it is also divisible by 3. So by this rule if two given numbers are divisible by a number, then their sum is also divisible by that number. Okay. And the next divisibility rule is that if two given numbers are divisible by a number, then their difference is also divisible by that number. Just like previous one only, there we are adding, here we are finding that difference, means we are subtracting. Okay, let us discuss with one example. I am taking 16 and 56. 16 is divisible by 8 and even 56 is also divisible by 8. Now the difference between 56 and 16 is 40. Here 40 is also divisible by 8. Okay. Let us take another example, 9 and 12. Here 9 is divisible by 3 and even 12 is also divisible by 3, and the difference between 12 and 9 is 3 and 3 is also divisible by 3. So we can say that if two given numbers are divisible by a number, then their difference is also divisible by that number. This is the last divisibility rule. Okay, children? Okay. In previous classes, children, you people learn about prime numbers and composite numbers, right? Here we are learning about prime factorization. Means, children, prime factorization means splitting a number, splitting a composite number into the product of prime factors is called prime factorization. Means, children, every composite number can be expressed as the product of primes, and this factorization is unique apart from the order in which the prime factors occurs. See, uh, we can split any composite number into the product of prime factors. Here I am explaining the with example 36. 36 I am taking and I am writing this 36 as the product of prime factors. First I split it into 9 into 4. Here 9 and 4 both are not prime numbers. So again I am splitting that 3 into 3, 2 into 2. Here finally we got all prime numbers, means 3 multiplied by 3 multiplied by 2 and multiplied by 2. Okay. So 36 I can write as the product of prime factors. Okay. Or else you can split like this also. 6 multiplied by 6 and then 2 multiplied by 3 multiplied by 2 multiplied by 3. Here in the definition we said that this prime factorization is unique apart from the order in which the prime factor occurs. See, in the previous one we got 3 multiplied by 3 multiplied by 2 multiplied by 2. But here we are getting 2 multiplied by 3 multiplied by 2 multiplied by 3. We can write the product in any order. Okay. The next I splitted that 36 in as 18 into 2, and that is 2 multiplied by 9 multiplied by 2, that is 2 multiplied by 3 multiplied by 3 multiplied by 2. This is the different order. Okay. So we are splitting that 36 into product of prime factors, and I am saying that this prime factorization is unique apart from the order in which the prime factor occurs. Like this you can discuss with any other composite number. So finally we can say that prime factorization is nothing but splitting a composite number into the product of, splitting means expressing a composite number into prime factors. Okay.